I am a skeptic. An alarm about global warming became stronger, and the proposal to control it more invasive. I decided to study the issue. I have a strong background in computers, statistics, and science. It seemed that the strongest advocates of global warming were the ones who benefited from it. They have highly paid jobs and investments. They have fervent believers like a religious cult, groupies who cannot whatsoever explain the science behind the threats they find so fearful. Being skeptics brings us no benefits. We get attacked, ridiculed, and fired for giving our opinions. Nonetheless, many brave climate scientists have changed their minds and written books about why the fear is overblown. I have read the books. They are credible. There is nothing in it for me being a skeptic except making a better world for my grandchildren. I don't want the planet to be destroyed. I also do not want to see my grandchildren's lives controlled by totalitarians. It is based on a theory, correct as far as it goes. Sunlight arrives during the day. Since it has a short wavelength that passes through the Earth's atmosphere without warming it up, it heats the surface of the Earth. The Earth re-radiates heat at night. The wavelength is much longer, and carbon dioxide absorbs the heat. Since the amount of carbon dioxide in the air is increasing, more heat is captured. This is the primary theory about global warming. While valid, it downplays other factors. Since it is a global problem, the United Nations took the lead in dealing with it. The UN is a confederation of 193 countries, about 35 of them rich, the rest not so much. The politics have always had money flow from the rich with guilty consciences to the poor with abundant needs. The excuses start with the exploitation of raw materials, pollution, and environmental damage. After that comes slavery and colonialism. Global warming fit right in. The rich countries are melting the ice caps and the poor countries will drown. Some UN officials have been so indiscreet as to state openly that their mission is global income redistribution. The United Nations set up a climate control bureaucracy called the Intergovernmental Panel on Climate Control. Participants include climate experts from research institutions around the world. UN members fund the IPCC and provide advice. The IPCC in turn gives funding and advice to research institutions. This gives them powerful control. Many bureaucrats are involved at the UN level and various donor countries. Their handsome salaries depend on global warming being real. Determining what is going to happen to the climate requires the most complex computer model ever devised. It is so complex that no research facility could possibly develop a model from scratch. They all have to use a number of components developed elsewhere. The IPCC distributes components, which assures that its point of view is well represented in most of them. Collecting inputs is a very complex worldwide effort. The IPCC coordinates standards for data measurement and collection. All of the data is held in common. All models use more or less the same data. The list shown on the slide barely scratches the surface of the measurements that go into the model or modules that make it up. It is hugely complex. The major outputs are an estimate of what temperatures have been and what they are going to be. The IPCC is organized in a 3x3 structure. Functionally, there is the science of climate change, what causes it and how to measure it. A second functional group estimates the damage caused by global warming. The third group develops policy for what to do about it. All three functions are performed at three levels. At the working level, scientists develop papers. Editors write technical summaries for the scientists to share. Lastly, the IPCC produces executive summaries for the public and the press. At the working level of this 3x3 matrix, it's mostly staffed by physical scientists, physicists, ecologists, and others. At the next level, there are technical writers and political scientists. At the summary level, producing information for the public and the press, you have Greenpeace, or you used to have Greenpeace at the time of Kyoto. This resulted in some embarrassment. They claimed, for instance, that the glaciers in the Himalayas would melt by the year 2035. The scientists said, "We didn't say that." A young University of Massachusetts scientist named Michael Mann managed to get the infamous hockey stick graph included in the 2001 report with the slogan, "It's hotter now than the last 1,000 years." Al Gore exaggerated the hockey stick in his movie An Inconvenient Truth. The IPCC eventually backed down, but when the fraud was uncovered, the damage to their credibility was lasting. The IPCC has reduced the presence of Friends of the Earth and Greenpeace, but the people who write the executive summaries are still advocates. Let's go back in geological history. When the Earth was young, the Sun was 30% weaker than today, but the Earth didn't freeze. When it was 85% as old as today, the Sun had warmed almost up to today's level, but the Earth had become a giant snowball. There are many factors at work. When there is more cloud cover, there is less warming. Radiation gets reflected back into space. More clouds, less heat. Major reasons for there being more clouds are first, dust particles. More dirt in the atmosphere provides more opportunity for water vapor to condense. You've all seen vapor trails left by airplanes. You're familiar with smog. Another source of cloud cover is cosmic rays. Cosmic rays ionize molecules in the atmosphere, around which clouds can form. More cosmic rays, more clouds, less heat. Cosmic rays are related to sunspots. Fewer sunspots, more cosmic rays. A dame named Svensmark developed this theory. He needed the nuclear collider in Switzerland to test it. The IPCC blocked his access for several years. When he finally got permission, lo and behold, his theory was true. Solar activity, sunspots go in cycles. So does the Earth's temperature, much more than the IPCC models typically show. Volcanoes, which erupt along the edges of tectonic plates, have been a major factor in climate change. When a volcano such as Mount Pinatubo erupts, it spews ash into the air, causing a cooler than usual year. However, the CO2 emitted forces global warming over the long term. The Earth's tilt changes on a 25,000-year cycle. More tilt means more warming toward the poles. The Earth's seasonal orientation changes on a 40,000-year cycle. Its distance from the Sun changes. These significantly affect the amount of solar radiation it receives, contributing to climate variation over geological time. Carbon dioxide and methane are major greenhouse gases. Where is the Earth's carbon? It makes up 0.07% of the Earth's total mass. 99.8% is locked in the Earth's core, chemically inactive. 0.11% is in the Earth's crust, from which volcanoes can throw it into the atmosphere. 9.2 millionths are dissolved in the oceans as weak carbonic acid. 2.3 millionths are locked up in methane cathrates on the ocean's bottom. 1.1 millionths are in coal, oil, and gas beds. 0.46 millionths are in biomass in the soil, and 0.18 millionths are in the air as CO2. 600 million years ago, in the age of the trilobites, before life on dry land, carbon dioxide was 20 times higher than today. It was 10 times higher in the age of the dinosaurs. Since man has been on Earth, it has been between 180 and 280 parts per million. However, since the industrial age, it has crept up to 400 parts per million and seems headed higher. How they know and how confident they are is a fascinating topic. They measure isotopes, analyze ancient seabeds for glacial activity, measure the calcium in ancient sea animals, and rates of chemical reactions long ago. Temperature over this period has gone up and down, but it seems to be back right about where it started. There is not much correlation over the long term between CO2 and temperature. Zooming in 1,500 times to the short period man has been on Earth, we see a cycle of ice ages driven by many factors named above. Temperatures often much colder and sometimes a bit warmer than today. Overlaying the graphs, you can see that ice ages have all followed similar patterns. History would say that the Earth is due for a gradual cooling. By the IPCC formula, doubling CO2 raises temperature 2.5 degrees. If we burned all the fossil fuels on Earth, CO2 would quadruple. It would raise temperatures by 5 degrees. But it won't, if only because we can't get them all. Besides that, we are working feverishly on alternatives. Global warming has been a concern for 30 years now. There has been a vast amount of research and vast political and financial investments made in alternatives. People cannot easily give up those investments, but the fact is that since the year 2000, CO2 in the atmosphere is up 8%, but the temperature is almost unchanged. The diplomacy reflects this. Back in 1997, at the Kyoto Conference, many countries made a serious attempt to cut carbon emissions. The Europeans and Japanese were quite successful. They cut fossil fuel use and increased solar and wind power. The United States and China were not so serious about it. By the time of the Copenhagen Conference in 2009, they were not so serious. Climate activists were disappointed that there were no binding agreements. By the 2015 Paris Conference, they had set their sights much lower. They were willing to accept national promises to continue to do their best. The only firm commitment was to continue the process and to keep those bureaucratic salaries coming. The concern about global warming has had several beneficial effects. It has spurred the development of renewable energy, such as solar and wind. Brazil and African countries have taken measures to slow deforestation, a good environmental result. World attention has focused on the environmental damage that fossil fuels are doing. Extracting oil from tar sands in Canada and shale in the United States is environmentally messy. Likewise, the process of mountaintop removal in order to mine coal devastates all regions. The world needs alternatives. Lastly, there is a chance that the global warming frenzy did slow some global warming. We don't know for sure what would have happened to temperatures if carbon levels had risen more. Here are some trends that the models should but probably don't fully take into account. No rich country on the earth is reproducing itself. North Asian and white populations are shrinking. We are coming up with self-driving cars, a big impact. Because most of the weight of a car is protection in case of accidents, we can make them lighter. Make them have less sex appeal. Make them have shared use. Make better trucks. Transportation accounts for 23% of energy use. That will come down. We have much better light bulbs than we did 10 years ago. They're about 7 times more efficient. The insulation in my new house is probably 3 times more efficient than in your old apartment. Heating and lighting account for 42% of energy use. Lastly, there is a resurgence of interest in nuclear power, which is environmentally very clean. There are more new nuclear plants on the drawing board than there have been for 25 years. So, bottom line, we should cut fossil fuel use for any number of reasons, but don't panic. We're not going to drown tomorrow. I am a skeptic. You should be too. I invite you to stop the video and take a note on my references. I've uploaded a copy of this PowerPoint, the script, and my bibliography to the website. I hate being manipulated. I have no interest in global warming aside from the well-being of my grandchildren. I invite you to decide for yourself. It's not that complicated.